we're going to start having conversations about polynomial functions. Polynomial functions. And here are some characteristics of functions. Okay, functions, what do they have to pass for something to be a function? The vertical line test, okay? If x repeats, it's not a function. What does it have to do to be a one-to-one function? Horizontal line test. If something doesn't pass the horizontal line test, it's still a function. It's just not a one-to-one function. Today, and really for the next week or so, we're going to talk about polynomial functions. Polynomial functions. And they have some characteristics. They are continuous. That means they do not stop and start. So our piecewise functions that we dealt with last chapter, they are not polynomial functions because they are not continuous. The domain for polynomial functions always is all real numbers. If the domain of a function is not all real numbers, then it's not a polynomial function. Okay? Okay, so all real numbers is the domain for polynomial function. Now, because the domain has to be all real numbers, what does that mean a variable cannot show up in? So think back to last chapter. We had to limit our domain in two situations. When did we have to limit our domain? Yes, okay? So a polynomial function cannot have a variable in the denominator. Okay? Now I can have a number in the denominator, but I can't have a variable in the denominator. Denominator, okay? When is the other time that we had to limit our function? Okay, what's inside the square root can't be negative. So you cannot have a variable inside a square root. Okay? Okay, so for something to be a polynomial function, you can't have a variable in the denominator and you can't have a variable in the square root. Okay? The graph of a polynomial is smooth. And when it changes directions, it has a curve to it. It's not a sharp point like your absolute value. So absolute value is not a polynomial function. Okay? Your exponents have to be whole numbers. Your exponents have to be whole numbers. Okay? These are the characteristics of polynomial functions. Now let's look at some examples of polynomial functions. Okay? These are all polynomials, and these are examples of some of those. I can have a constant. A constant's a horizontal line. That's a function. It's also a polynomial function. Okay? The degree of a constant is 0. I don't have a variable. So the degree of that is 0. That is a horizontal line. A linear function is also a polynomial function because it's a straight line. It goes on forever in both directions. The degree of that is 1. The degree of that is 1. We talked extensively about quadratics on Tuesday. That is a polynomial function. The degree of that polynomial function is 2 because my exponent is raised to the second power. And that is my highest exponent. You determine the degree of your polynomial by your highest exponent. Okay? The next one's a cubic. Cubic is a variable raised to the third power, and that's my highest exponent raised to the third power. we know what that looks like because we kind of talked about, or we did talk about parent functions of a cubic. Quartic is if my variable is raised to the fourth power. Quartic is if my variable is raised to the fourth power. Okay? What we're going to focus on now is the behaviors of these graphs. The behaviors of these graphs. Okay? So, I know this is a little bit small, but I'm going to write a lot of stuff off to the right. You have something called a leading coefficient test. A leading coefficient test. To look at the leading coefficient, you have to look at the term that has the highest exponent. It doesn't matter which order that you're in. You have to look at the term that has the highest exponent. So your leading coefficient is the term with the highest exponent. And you only look at the highest exponent. You don't look at, like if you've got x to the third power, the x to the second power doesn't matter. You're looking at the highest term, the highest exponent. Okay? Now, one of two things can happen. You can have a polynomial where that exponent is odd. Okay? That includes x to the first power, x to the third power, x to the fifth power. Okay? So anytime your highest exponent is odd, the end behavior of that graph is that the ends are going to go in a different direction. So think about a line. Okay? If I have a line, it goes in different directions. One goes down, one goes up. If my slope is negative, it goes the other way. One goes down and one goes up. Okay? If something's raised to the third power, the same thing is true. One of the ends goes down and one of the ends goes up. If it's raised to the fifth power, one of the ends goes down and one of the ends goes up. So the end behavior of this, end behavior, is opposite direction. Okay, the end behavior of my graph is opposite direction. That is when my exponent is odd. My exponent is odd. Now, I want to talk about the leading coefficient. The leading coefficient. The leading coefficient is the number in front of that variable with the highest exponent. It has to be the term with the highest exponent. So, when I have a positive leading coefficient, my graph starts in the bottom left and it goes up to the top right. Okay? That right there is what happens when I have an odd exponent and my leading coefficient is positive. That's going to be the shape. Odd exponent, leading coefficient positive. We don't know what happens in the middle, but that's what the end behavior looks like every single time. It has to, by definition. Now, if my leading coefficient is negative, it's going to look like a line does when it has a negative slope. It's going to go from the top left to the bottom right. Okay? And there are times that I have to draw that out to think about it. So don't hesitate to draw a line. Think about the stock market. If my line's going up, I'm gaining money. That's positive. The line's going down, I'm losing money. That's negative. Okay? The end behavior of an odd exponent is harder to visualize than the end behavior of an even exponent. Okay, so focus on that one. The end behavior being even is a little bit more clear because we understand how quadratics work. So when n is even, such as x squared, x to the fourth, x to the sixth, my end behavior is that it goes in the same direction. Think about our quadratics. Okay? So if my highest exponent is even, I'm either going to be going both up or both down. Okay? Now, if my I'm going to kind of do a line right here just so we don't. If my leading coefficient is positive, think back to Tuesday. If my leading coefficient is positive, what's going on with my end behavior? If my A is positive, both up. Okay? They're both going up. My end behavior, both up. Okay? If my leading coefficient is negative, what's going to happen? Both down. Okay. This is a good screen to take a picture of. Make sure you've got this. Okay? Can I go to the next screen? Okay. Now, Desmos is a tool. Desmos is a tool. And it is reasonable to check yourself using Desmos. Do not get so used to Desmos that you can't do these on your own because you cannot use Desmos on your test. Okay, you will not be using Desmos on your test. Okay? So be sure you understand the concepts behind these graphs. So what I want us to do with this one, I've got f of x equals negative x to the third plus 4x. I want to know my end behavior. So based on my exponent, my highest exponent, is my end behavior going in the same direction or opposite direction? Opposite. Good. Okay, so we know that I'm going in opposite directions. And the reason we know that is because my highest exponent is a 3. Okay? So my end behavior is opposite direction. Now, there's only two options. I can go this way or I can go this way. So am I going based on the number in front of x to the third? Am I going bottom left to top right or top right to bottom, or top left to bottom right? Top left to bottom right. Why? Because of the negative, okay? This right here is because of the odd exponent. Okay? This direction is because of the negative coefficient. Okay? Let's check ourselves. Okay? Now, we haven't talked about how to determine what's happening in the middle. So we don't need to worry about this. All I want to know is, did we get our direction right? And we did. Opposite direction, top left, bottom right. So we did good. I actually think that's the hardest one. Okay? I think the others are easier. Okay, let's look at the next one. F of x equals x to the fourth minus 5x squared plus 4. So I want to know end behavior, and I want to know direction. End behavior and direction. Okay, so end behavior, because of my exponent, are they going opposite directions or same directions? Same. Okay, and that's because of my 4. Okay, so they're either going both up or both down. Okay, because of my leading coefficient, what does that tell me? They're both going up. And that is because my leading coefficient is positive. Okay, so this is not correct. The correct answer is this. Okay, and that squiggly line just means we don't know. We don't know what's happening in the middle. We're only talking about end behavior. And we are correct. Okay, the ends are both going up. Okay, opposite directions or same direction? Opposite. That's because it's raised to the 5th power, so it's opposite. Okay? This, which is bottom left to top right, or top left to bottom right? Good. And whenever you get confused about that, pull the ends and make a line. Okay? This is a positive slope. This is a negative slope. That can help you with that. So this one, opposite direction, bottom left to top right. And we did it. Okay? One more. Negative x to the 4th plus 3x to the 3rd. Same direction or opposite directions? Same. That means each end is either going up, they're both up, or they're both down. Which one? They're both down because of the negative. Okay? Both down because they're both negative. Okay. Now I want to hang out on this slide for just a couple of minutes. And I want you to look at this area right here. And I want you to look at this area, these two areas. Okay? What we're going to do now is we're going to start learning how to identify what is happening in the middle of the graph. Okay? So we're talking about what's going on in the middle of those graphs instead of the end behavior. We've already got our end behavior under control. So now we want to know what's happening in the middle. What is happening close to the -2 and close to the +2? What's happening there? It crosses the x-axis. Okay? It's crossing the x-axis. Okay? So we're crossing. What's happening at 0? It touches it, and then what happens? Right, that's exactly right. It touches it, and then it changes direction. So our graph is behaving differently at 0 than it's behaving close to -2 and close to +2. And there's a reason for that. We just don't know what it is yet. But there is a reason for that. So I want you to notice what I have here is I have a graph that crosses the x-axis in some places, and I have a graph that touches the x-axis and changes direction in other places. Okay? So, what that is called is multiplicities. It's called multiplicities. That's when a solution and a factor show up multiple times. So if I have a solution that shows up 2 times, or 4 times, or 6 times, it is going to touch the x-axis and then change direction. It's not going to cross. So if I have an even multiplicity, my graph does not cross. Okay? If I have an odd multiplicity, the graph crosses the x-axis. Okay? So if I were to draw a graph right here, if I had an odd multiplicity, it would cross. Let me go back. Okay, and it doesn't matter if it's to the 3rd or to the 5th or just to the 1st. If I've got an odd multiplicity, it's going to cross. Okay, if I've got an even multiplicity, it's going to touch it and it's going to change direction. Okay? So let's look at exactly what that means. Let's look at exactly what that means. Now this is in Desmos. So I am inside Desmos and I have graphed x to the 3rd plus 8x squared plus 16x. I have graphed that. Now, because of the x to the 3rd, we know my end behavior is going to go in 2 different directions. Okay? I have a positive coefficient, so I start in the bottom left and I go up to the top right. I can factor. What I want to do now is I want to find out my solutions. And the way that I find out my solutions is by setting this equal to 0 and factoring. And you know how to do this. You've been doing this for years. Okay? So I'm going to take my f of x and I'm going to set it equal to 0. And I have x to the 3rd plus 8x squared plus 16x. And I know how to factor this. The first thing that I do is I look for a least common or a greatest common factor that I can take out of all of it. What shows up in every single term? X. So I'm going to pull an x out. So I have an x, and then I've got x squared plus 8x plus 16. That is a trinomial that I know how to factor. Okay? And all the stuff that we work on this weekend will be factorable. What 2 numbers multiplied together give me 16 and added together give me 8? 4. Good. 4 and 4. So this is what I'm talking about here. Do you see how this factor shows up twice? That has a multiplicity of 2. That's what that means. Okay? Do you see how this x, I just have it show up once? What's the exponent with that x? Okay? So I can write x equals 0, x plus 4 equals 0, and x plus 4 equals 0. So I get x equals 0, x equals what? Good. Now you don't have to solve that twice, but you can. Here, it shows up twice. My solutions to this, are x equals 0 and the multiplicity of 0. How many times did 0 show up? 1. Okay, then another solution is negative 4. How many times did my negative 4 show up? Twice. Okay, so at negative 4, I bumped and went back down. But at 0, what happened? I crossed. That's how multiplicities are important. Here, my solution of negative 4 has an even multiplicity, so I touch the x-axis. Here, my solution of 0 only shows up once, so it crosses the x-axis. Okay? Okay. Here's another one that we're going to look at. I have x to the 5th plus 4x to the 4th plus 4x to the 3rd. Okay? I am touching the x-axis here and changing direction. What does that tell me about this multiplicity? Before I even solve it, what does it tell me? It's even. Okay? This looks crazy. Doesn't that look a little different? But does it cross the x-axis? Yes, it crosses it. Now something different is happening here. We're going to have to solve it to try and figure out what, but it still crosses it. So what does this tell me about the multiplicity? It's odd, and there will be an exponent associated with that. An even exponent associated with the factor that has a multiplicity of 2, and an odd exponent associated with the factor that's associated with the solution of 0. So let's factor this and we'll see exactly what it looks like. Okay, so I'm going to set it equal to 0. I have x to the 5th plus 4x to the 4th plus 4x to the 3rd. What's my GCF? X cubed. I can take an x cubed out of that. And that makes this a lot simpler. Once I take x cubed out, I'm dealing with a much easier trinomial to deal with. So then I've got x squared plus 4x to the 1st plus 4. Okay? Can I factor x squared plus 4x plus 4? I'm looking for two numbers multiplied together that give me 4 and added together give me 4.
2 and 2.
Okay. Now, x to the 3rd, it means x times x times x. Is that what x to the 3rd means? Yes. Then I am multiplying that times x plus 2 times x plus 2. Okay? So I could set x equal to 0. I could set another x equal to 0. And I could set another x equal to 0. Then I could set x plus 2 equal to 0 and x plus 2 equal to 0. How many times do I get x is equal to 0? 3. Okay, I don't have to write all those down. I really don't. And I wouldn't write all those down. I'm just showing you what's happening. So my solution here is a 0. What's the multiplicity associated with the solution of 0? 3. Here, I get x equals negative 2. And how many times do I get x equals negative 2? 2. Now, I want to show you a couple of things. What is 3 plus 2? What's my highest exponent? 5. It always works that way. Always. Okay? Now, I kind of went crazy right here. Okay, I was just trying to help you to really see what was going on. I don't have to write it that way. I could write this 0 equals x to the third times x plus 2 squared. This and this identify my multiplicities. So I could put x to the third equals 0, and I could put x plus 2 equals 0, because I'm going to get the same thing. Those exponents are associated with my multiplicities. Now, going back to my solutions, we know here we had a multiplicity of 2. So we touched it and we changed directions. Here we had a multiplicity of 3. Okay, that means it happened 3 times. That factor showed up 3 times. That solution showed up 3 times. It still crossed the x-axis, but it definitely did a different movement there. Okay? It crossed the x-axis, but it ran tangent to it and then kind of went off at a different shape. Okay? When it was just a multiplicity of 1, we just go straight through it, and it's a little cleaner. Okay, now, there's no more new information today. We just have to put it all together. Okay? So that's all we're doing right now, is we're putting all together what we've already talked about. We ready? Okay. So, let's look at this. I don't want you to use Desmos until the end. Don't use Desmos until the end. Okay? I have f of x equals negative 2x to the fourth plus 2x squared. The first thing that I want to do is I want to determine the end behavior. Now, to determine the end behavior, the only thing I look at is this leading coefficient. Negative 2x to the fourth is my leading coefficient because it is the highest exponent, not because I come to it first. Okay? If I rewrote this as f of x equals 2x squared minus 2x to the fourth, my graph would look exactly the same. And this is still my leading coefficient because it has the highest exponent. So don't get caught in this idea that my leading term or my leading coefficient is whatever I come to first, because it's not. It's got to be in order. So your leading coefficient and your leading term is your highest exponent. Okay, so we've got negative 2x to the fourth. That tells me 2 things. What does it tell me? In behavior, they both go down. Both go down. Actually, you told me what I needed to know. They both go down. Okay? So, my end behavior is my ends go in the same direction and they both go down. Okay? So that is the answer to the first part of this. Now, the second part of this, find their zeros and their multiplicities. What I have to do for that is to factor. And I just want to put another plug. If you're struggling with factoring, there's a whole page under the review unit on how to help with factoring. So don't hesitate to go back and review that, because that will come up. We have to factor. On Tuesday, we'll talk about what we do when a polynomial can't be factored. Okay? So what I do for number 2 is I'm going to factor. So I've got 0 equals negative 2x to the fourth plus 2x squared. I am going to factor out a negative 2. A negative 2. And I'm going to factor out an x squared. That's my GCF. Negative 2 and the x squared. Then I'm left with x squared minus 1. What is x squared minus 1? Good. It's the difference of perfect squares. X plus 1, x minus 1. Okay? Now, I'm going to set negative 2x squared equal to 0. That's x equals 0. X plus 1 equals 0. X equals negative 1. X minus 1 equals 0. X equals positive 1. Okay. So I have a solution. My first solution is 0. What's the multiplicity of 0? 2. It shows up twice. The reason that we know it shows up twice is because of this x squared. Do you see that? That's how we know that this shows up twice. How many times does negative 1 show up? Once. That multiplicity is 1. How many times does 1 show up? Good. Okay. Now, before you pull Desmos out, because you are not going to have Desmos on your test, before you pull Desmos out, I want you to graph it. Okay? I am crossing or touching the x-axis at 0, negative 1, positive 1. My end behavior is that they're both going to go down. That's my end behavior right there. Okay? Here, am I crossing or am I bumping? At negative 1, do I cross or do I bump? Cross. At 0, what happens? I bump. That just means I change direction. I don't cross. What happens at positive 1? Cross. Okay? So this gives me all the information that I need. Okay? My end behavior is both going down, so I have to start going down. And then I cross. And then I bump. And then I cross. Okay? Now, we don't know the maxes to this. Okay? Our relative maximums, we don't have enough information to figure that out. So I'm not looking at how far up you put these. I'm not worried about that. I'm looking at where it crosses the x-axis and its behavior at the x-axis, and I'm looking at its end behavior. That's what you can tell me from this information. Now, at this point, while you are working on homework and while you work on your quiz next week, it is reasonable to, at this point, put it in Desmos. Do not rely on Desmos too early. Okay? Okay. Now, on my graph, I made these much higher, didn't I? Okay? That's because we couldn't tell from that information what was happening here. So this is what I'm looking for. These points in this behavior down here. Okay? Let's do another one. Okay. 3x to the 4th minus 4x to the 3rd. The first thing that I want to know is end behavior. End behavior. What can you tell me about end behavior? Both go up. So the ends of my graph, they go in the same direction. And we know that because I am raised to the 4th power. The degree of this is the fourth power. My highest exponent is the fourth power. They both go up because my 3 is positive. So I am looking at something like this. Okay? So that is the first part. That's my end behavior. The second part is the behavior at the x-axis. And I factor. So I have 0 equals 3x to the fourth minus 4x to the third. Yes?
So you said we didn't know how high it was. Is there any way to determine how high or
We will not be given the tools in this class to determine that. But yes, there is ways to do that. You could plug numbers in and do a table of values. That would be a longer way to do it. But yes, I mean, there are. It's not an expectation in this class that you have to do that. But it is just really plugging it in. And then you'll be given other tools later on. Okay? So I'm going to factor this. What can I factor out? X cubed. Isn't it nice that we can factor out x cubed? Okay. We're going to have some multiplicities there, aren't we? Okay, so I've got x cubed equals 0. Okay, that's the same thing as x equals 0, x equals 0, and x equals 0. We don't have to write that down 3 different times. How do I know it happens 3 times? Because it's to the third. That's how I know it happens three times. So I have 0 for a solution. And the multiplicity for 0 is 3. Okay? My other solution comes when I put 3x minus 4 equal to 0. Okay? So I have x equals 4 over 3. So my solution is 4 over 3. How many times does that happen? Once. It happens once because I don't have an exponent outside those parentheses. Now, I can graph this. How big is 4 over 3? A little more than 1? Okay, -1. Oh, goodness. Okay. So I cross at 0 and I cross at a little over 1. Okay, a little past 1. What is happening at 0? Am I crossing or am I bumping? Crossing. Okay. What happens here? I cross. Now, the behavior when I have a multiplicity of 3 looks different than what happens with the multiplicity of 1. It looks different, but it still crosses. I feel like I have made a mistake. Because both of them are going, oh, no. I know what I'm doing. Okay. It crosses very cleanly at 1, right? It does the weird thing here. So, my end behavior is that they're both going up. So it's going to be going up from here. I don't know how far down, but I'm doing something weird there. I'm still crossing it, but it doesn't cross in the same way that a single multiplicity does. Okay? And it runs closer to the x-axis and turns different. So that's what I'm looking for. Again, you can't tell me what that is. You don't know what it is. Okay, unless you plugged in a bunch of points, and you're going to be plugging in a bunch of fractions, so you don't want to do that. Okay, so let's check Desmos. There it is. There's the behavior. Okay, here's positive 4 over 3. I turn, here's my weird behavior right there. Okay, so I'm looking at the end behavior, I'm looking at the shape, and I'm looking for what happens at x. So I am going to give you one to try on your own. Okay, I'm going to give you 3 minutes to do this, and I'm going to step out and run to the restroom. What is this technique called that we're using to have to factor here? Good. So you look at the first two and then you look at the last two. That's factor by grouping. Okay, again, I'm very hopeful that you are remembering how to do this factoring. Again, if you don't know how to do the factoring, there's resources online to make sure that you're sharp with that. Here, what I did is I looked at these first two terms, 2x to the third plus 3x squared, and I saw that I could take an x squared out of both of them. Okay, so I factored out an x squared. Then I looked at my second set of terms. Because there's a negative right here, that's a good indication that you're going to have to take a negative out of it. So negative 4 comes out of both of those, and I'm left with x squared minus 4 times 2x plus 3. Now, hopefully, you are able to identify x squared minus 4 as the difference of perfect squares. Okay? X squared minus 4 is x plus 2 times x minus 2. Okay. At this point, you should be able to tell whether or not I have multiplicities of 2 or 3. Do I? Do I have any multiplicities here? No. All of these are going to show up once. Okay, which is kind of nice. The multiplicity of 1 shows up much more often than today would suggest because we've done so many with multiplicities. So I'm going to set each one of these factors equal to 0, and I'm going to solve. Okay, so I can have x equals -2. The multiplicity for that is just 1. I have x equals 2. Okay, and then my last one is 2x equals -3, and I divide by 2. So x is -3/2. Yes?
Okay, so since it comes up twice, we don't write it. It doesn't come up twice?
Well, -2 and 2 are different. Oh, were you talking about in the factoring?
Yeah.
Are you talking about in the factoring right here?
Yeah, the x plus 3.
Okay. The 2x plus 3 shows up twice?
Mm-hmm.
Well, but that's part of the factoring. So really what 2x plus 3 is the greatest common factor. And so it has to show up twice for us to be able to do factoring by grouping.
So you use it once.
You only write it down once, yes. Okay? So my solutions are -2, 2, and -3/2. Or, I'm sorry, yeah, -3/2. Write those a little bit smaller. Good. And the multiplicities for each of those is 1. Multiplicities for each of those is 1. Okay. Now, my leading coefficient is this 2x to the third. That's my leading coefficient. Because of the x to the third, my end behavior is going in opposite directions. That's because my exponent is odd. Because my coefficient is positive, it has the shape of bottom left to top right. Okay. I'm running out of space, right? Okay. Okay, so I am crossing the x-axis at +2, I'm crossing the x-axis at -2, and I'm crossing the x-axis at -1.5. That -3/2, that's -1.5. So it's right there. So I go up, I go down. My y-intercept is very low. Okay, this is actually my y-intercept. We'll talk more about how we can identify our y-intercept a little bit later. You have done that before, but our y-intercept on this is -12. So let's see how well we did. Okay, you can see the y-intercept down there. I still have 5 minutes. Please don't back up. Okay. It's going in opposite directions. I cross at -2. I cross at -1.5. And if you look closely, -1 is right here. -1 is right here. It's just that our scale there is -2, just because we had such a. It's because of the y-intercept is so low. That's why our scale looks a little different. Okay? Desmos is a tool. Do not use Desmos so much that you don't know what to do, because you can't use Desmos on your tests. Okay. Now, I want you to think about this. I want you to think about this graph. I'm giving you a graph. Do we have enough information to come up with an equation? Okay? The end behavior here, is it acting like an exponent is the highest exponent is even or the highest exponent is odd? Odd. Okay? So my highest exponent is odd. Okay? Is my coefficient positive or negative? It's positive. So I have a positive leading coefficient. Okay. Now, here, that is a solution. What is the solution? -2. Okay? -2 is a solution. What's the multiplicity of that? It's even. Okay? So, yeah, I guess you're right. You don't know for sure if it's 4. I was thinking that we could say it's 2, but you're right. We really can't. Okay? What's another solution? 1. Okay? What's the multiplicity of that one? It's odd, and because it just kind of goes straight through, you really can say that it has a multiplicity of 1. Now, this is the jump that you have to make. This is the jump. If 1 is my solution, what is the factor associated with 1? Okay? So, here, x plus 2 is my factor. The solution associated with this factor is -2. So x minus 1. Yes, you're absolutely correct. So if 1 is my solution, x minus 1 is the factor associated with it. Okay? If -2 is my solution, what's the factor associated with it? Not x squared. X what? X plus 2. Now, this is what we square. Okay? We square the factor that's associated with the solution because of this multiplicity. Now, we don't know for sure, because you're right, okay, this is even. The fact that it bumps tells me that it's even. But the simplest problem is that it shows up 2 times. Now, if I multiplied all this out, could I get a polynomial? I could. Okay, I would have to FOIL this, then I would have to multiply this, the trinomial I get right here, times x minus 1. Okay? We will get there. Just start thinking about this. Start thinking about this. Okay, I will see you on Tuesday. Have a good day.